Hello, we are now on the second part of our turn-based combat system that I have created and I am going to explain. We are now on the second core aspect, which is the systems. In the previous part, we talked about the characters, how each character has 5 important pieces to them, 5 important scripts that's attached to each character, and how by all of them weaving together, they're able to give the character life, giving them ability to take actions and to store values within them. And now we're going to talk about the systems that essentially brings these characters into life. Now, before we talk about all the other systems, we need to show the difference between a player character and enemy character. With these enemies, they do have that health bar above them, which contains that slider in which you shows their HP. They have this HP bar and HP object actually filled in. Next, we have their enemy behavior script. Enemy behavior right now works very simple. You have that intelligence, which just goes and returns their stat template and grabs their reference and grabs the level. That's back in that scriptable object. Stores a cooldown and a timer for that cooldown. On start, you reset your cooldowns, so that cooldown timer will equals back to cooldown, and you go through this public void action in which the animator calls this enemy action, right? So if the cooldown timer and the enemy significance means it is an elite enemy, if that matches up, it will do a skill attack. First, it grabs its preparation, which aids in its targeting. The way this works is, let's take a look at enemy attacker, which is the enemy script. It needs to grab its targeting function first, and then next, it will go through the enemy attack, which goes through that animator and runs the animation. And then once a skill has been played, it will reset the cooldown, so it resets. And then next, if you are not doing a skill, you just do its basic attack. You grab its basic targeting through basic prep, then do the basic attack and goes through the animator again. This time, since it isn't doing a skill, it will tick down the timer until it can do another skill or when it reaches to 0. Enemy behavior is very simple in this preparation and this format. If we wanted to make it more convoluted, we can add different enemy significance levels, add more functions, add more skills and damage. We could also rely on either adding more modifiers in enemy attacker scripts. We can give them modifiers, we can give them special functions if we wanted to, but that is primarily the main difference between a player character and an enemy character. Now that we have gotten over all the characters, it is time to go through the second core aspect, which is the systems. We have 6 systems put in place. We have our turn-based combat system, our turn order system, our targeting system, party manager, input manager, and camera controller. These are installed in our game manager, that's under the tag manager, and we have 6 scripts here, plus our combat UI script. So these 6 scripts all work together in running the game. And first, let's look at our input manager. In input manager, it uses Unity's new input system in which we have a input action map right here. Right here, we have multiple ones that come base, and then we have the turn-based one, which has our left, right, basic, skill 2, in which we use. We use C# events instead of Unity events because I personally like using C# events. So first, we also do have a input selection enumerator that we have, which we have our selected inputs. And then we have a getter, which returns this. On awake, we create a new input system, and then we link up all of our input actions to our buttons, to our inputs that we linked up, and then we subscribe our input callback events to on performed of those actions. And then on the start, we have our selected input be done. And then we have multiple voids in either we want to enable actions, so using any of the skills, disabling them, selections, so if we want to enable left and right selection between characters, and then enable disable, and then all inputs, which is both of them, either selection and action, and then disable selection and action. And then we have our standard on enable and then on disable, which is calling our all inputs. We have a void, which is start of input, which will be touched upon once we get to turn-based combat system. What this does is we take our selected input and automatically put it on basic, and then we get our character to do our basic prep. Now, the way input selection works is we have our 3 different types of inputs. Now, the reason we have input selection is that if we didn't have it, anytime we would click a button, it would automatically do its skill. So for example, I were to click W right now. Oh, wait, okay. it did my ability already without me deciding. So the reason we have it is that it turns it into a double press type of situation where we click on a skill and says, oh, it pops up as the attack and we can read its effect. Essentially, we can able to back up. We either select it and then we select it again to actually activate it. So whenever we switch out of that attack. But at any point we click that same button again without clicking any other button, it activates the skill. The way this works is through the selected put enumerator. We have a switch case where by default, if it's not on the selected skill, it will switch that selected input into the desired ability and then activates its preparations. And then once you click that button again, when it is on that selected input, disable your inputs, actually go forward with your ability, return it back to none, and then turn off the UI. And then characters' behavior scripts will go off, and then that will be at the end of the turn as everything starts calculated. And then for left and right movement, we go through the targeting system and we have this scroll target function in which we go +1 or -1. Let's briefly touch upon this part in target system. In targeting system, we do have this scrolling targets function in which requires an integer. We reset the targeting. We have the index increase by the integer that we added in. We have a switch case based on the targeting type. If we're targeting allies, it will scroll through the allies. It will deactivate all other characters that we have, so we focus on the main character we're playing as. We deselect the previous character that we have. We switch our index to the character that we're selecting to, and then we select them. So it turns off the spotlight of the previous character and turns on the spotlight of the new character. And then same goes for enemies. Same goes with enemies. We focus on the main character. Apologies. With these ones, with the targeting allies, it turns on all the player characters that we have. But when we're targeting enemies, it only focuses on the active character that we're playing as. And then it does the same thing. We deselect the previous character that we were targeting, set the index to that new character that we were going to target next, and then select them. And then afterwards, we call the camera and have it go follow or look at what the new targeting style is. Going back to input manager, we do have reset game function and escape game function if we need to add that. But for this example, we didn't really initialize that because we're focusing on the main aspect of the turn-based game. Now that we talked about inputs, let's talk about our turn order system. So turn order works in a very fascinating way. I enjoy it quite well. The way it works is we have a list of characters, which is the order, and then we can have a public getter to return this private list. Next, we have a active character that we are saying that is the turn of that character. We have a public accessor of that character in which we return that character with the person within the order that is the current turn at that index, and we return it as the active character, or we return it as null if it doesn't exist. Now, values that we store, we have this as the current turn index, where we return this private integer right here with the public accessor. We have a setter in which we clamp it between its value to 0 and the max of the order -1 because of how Unity does its, or how coders start with starting the count with 0. Now, we also have a round counter. The reason we have this is just in case your games, you want to log how many rounds it's been. You want to have a log and history in between your actions and your enemy actions. We have the current initiative. We grab that from the active characters and we just get their initiative. And this is how we log their current initiative of the game. We have a few management functions in which we add a group into the order and then we sort the initiative, or we just clear the entire order itself. Now, turn management, we sort the initiative using that descending sorter that we have in our global namespace. Using that sorter, we go back to character manager. We compare our hash codes. Instead being hash codes, we compare our initiatives instead accordingly. And when we go back to turn order, we sort it through there. And then we use our combat UI and we update the display order for it so that we have it proceeding with the right person in charge. So we have a function for the first turn. We sets everything back to 0 and then sorts the initiative just in case. We call the next turn through here. We sort the initiative. We always sort initiative just in case anyone's initiatives gets updated throughout the game or throughout the round. If anyone's initiative gets changed, we might not have it be in the right order and the game might break. So of course we have to keep it active. Next, we get the current turn be the person who is active at their index. And if the current turn is greater than the order count, it will start a new round and set it back to 0 and then increase that round counter. If anything else, it will instead just increase that current turn and then go to the combat system and start that new turn. Now going from turn order, we are able to go into the main combat base system itself. So the combat base system, the turn-based combat system is the central hub for all the systems of the game. We have the system scripts, we have accessors for all of them, and then we do have prefabs. We store prefabs like game objects for now, just ignoring the previous thing I said, just for a quick little initialization on how spawning characters would work. And then next, we have a list of the player characters, a list of enemy characters, and their public assessors using their getters, returning the player characters and returning the enemy characters. Going off next, on the start of the game, we initialize it. For each prefab that we have, we instantiate it, and then we go through the player party manager, and we parent it to the transform of the player side, if it's a player. And then the same thing with enemy. For each enemy in the enemy prefab list, we add the enemy characters with the new instantiated enemy and having it parented to the enemy side. Now, the reason we do this is we will briefly talk about Party Manager. It is one small script. Party Manager is just this small script where we have two transforms, we have one function, and an enumerator. What this function does is that when a character dies, their death will be played and they'll be removed from the list of characters. And next, it will start a coroutine which waits for their death animation to finish. It also initializes the turn order again, and then it updates the player stat display just in case a player died. So it removes unnecessary UI, and then it checks if an enemy if all enemies are dead, characters win. If all players are dead, then the enemies win. And then if nothing happens, then we'll just move on to the next turn. Now, the very fascinating thing about this system, before in the past, I had a very, very unoptimized Imager script that I hated very much that stored 8 lists of 8 different transforms, lists. And oh boy, if you scroll through that, it is a pain to look at. So many for loops in 2 different switch cases. Oh my goodness, it was terrible. But now I found this nifty little trick. There is only 2 transforms, and you already saw how they worked, how they moved around. You may be wondering, what is this? It's a rect transform. These are 3D objects. Rect transforms are actually, so listen before, UI, right? Before, I was working on the party management, essentially lining up all the characters. I wasn't working a lot on UI until I did. What I noticed in UI, I was like, oh my goodness. I absolutely love the horizontal line groups. They're layout groups, essentially laying out every object. And I was like, oh my goodness, this is so wonderful. If only I could do this with 3D objects. It would be so much more easier to lay out all the characters instead of using that Imager script that I've been using. And then it hit me. Why shouldn't I try it? So I did. And then what I did was oh my goodness, let's pretend this cube was a character. It's like, okay, I have my character, I have my transform, I added a horizontal layout group. Okay, let's put it in. Oh my gosh. It didn't work. And then I thought to myself, why didn't it work? How could it be? I compared. Rect transform, alright, transform. I thought to myself, what if it was just a problem with transforms? So I gave it a rect transform, and boom, it snapped. It snapped to the end, and so it worked. The reason cubes are not working is because they're a little weird right now. I don't know where they're moving to. Oh, he's all the way at the other end. Yeah, see? So with these cubes, with these characters, they all have rect transforms. They're essentially UI objects or just a different transform. This is completely new to me, so I was a little bit unfamiliar and was glad I found this out. Now jumping back into the actual scripts. After initializing each player and enemy, we initialize that stat display for the characters. We add the player side and the enemy side into the turn order. So we have a full list of orders. We get the camera and open up the intro camera and start the intro, in which we start this enumerator where we have a for each loop that grabs every character in the turn order, have them do a little dance with the intro. Then we wait until that animation is done just by waiting a couple of seconds, and then we start the game. At the start of the game, we call back that turn order system where we call that first turn and we call for a start turn. We have this UI updater where we update active character of the game from the turn order to the active character, in which we have a nice little thumbtack which displays or which pins at the active character on that display board. And then we have the initiative UI, where we update the number that is right next to the list of all characters, just to signify who's what number of initiative we're on. Now, at the start of the turn, we have a switch case to check which type of character is starting off first. If it is a player, we turn off all the other player characters except the active one. And then we have that start of input where we go in automatically into basic attack and then enable the inputs of a character, and then the player takes action deciding what he wants to do. But instead, if it's an enemy, the enemy will go through its AI, it'll go through that character animator, it'll go through the enemy action, and then it will do all its calculations it needs to do. And then at the end of that, we'll update the UI for our UI buttons down here, and then update our display text that is right here. So to go over it again, UI objects are these yellow sticky notes. And then for our display text, it is this display text right here. It'll turn off if an enemy is active, and then it'll turn on when a player is active. These sticky notes are supposed to be UI buttons that we're able to click and able to select the skill through there. But for the sake of simplicity, and I still haven't implemented yet, which is a fault on my part, but I can't wait to work on that in the future. Next up, we have a change of targeting function, which we saw in the character stat scripts. We go through the targeting system and update the targeting type with the targeting type that we gave it, and then we update the display text with what the active character's skills are, and then its selected inputs. Moving on, we initialize turn order from the party manager script. What it does is it clears the group and adds the two groups again, this time with the changes that we made by removing them from the list. So for example, we were to update the players. A player died, so that means in the player list, we have -1 player. So when we initialize this, we have that player list with the -1 player and the enemy list. So instead of, let's say we had 8 people, now we're down to 7, 3, and 4. So instead of 4, 4, 3, 4. Yeah. Simple as that. And then we have the end of turn. At the end of turn, we turn off all the UI that we need to turn off other than the display board and the character stats. We have a for each loop that checks if any of the characters are dead for enemies. And if they are, we just return, and then we go through that party manager script, and then afterwards we check the characters. The reason we have it set up in this way is that if an enemy were to die before a player wants to die, we give that player a bit of leeway so that they can still win even though they're supposed to be dead. And now for victory and lose scripts, we disable our inputs. Player can sit back, relax. We turn on all of the characters again. We set them all active. In this for each loop, we make sure the rotation is set to just facing forward. We start a core routine in which all the characters in the for each loop, they go do their win animation. We set the camera to face towards them. We wait a few seconds, and the debug logger just says we win. And if we lose, exact same thing. Disable inputs, start the code routine. We go grab that win cam. It uses the same direction, so we use the same function. And then we wait, and then we just say you lose. Oh man, so sad. Now, next, we have two scripts, which is the targeting and camera script. They both work hand in hand together. So first, our initialized values and variables is we have our player characters and enemy characters, which we just steal from turn-based combat system. We just steal their characters. For target characters, turn-based combat system steals from targeting system, in which it just returns this character. It returns the private target character and just steals from the public getter. And then next we have a private integer for our index, but we do have another accessor for that index in which we lock it in the getter and in the setter. We have two switch cases, one in each. Switch case is for the targeting type or allies. Depends if the player character, if the integer of the index is higher than the player character amount, it'll just bound it back to the maximum, or else it'll just return the integer. And then if it's targeting enemies, it will do the same thing, but just with enemies instead. And then it repeats the same thing with random ally or random enemy. With the setter, we have a clamp in which the index will be clamped to 0 and the maximum of the player amounts. And the reason why our getter also needs to be locked is that in some cases, we don't set it within the bounds in time. So instead, we have a failsafe in which if it ever goes over, it just goes back to the max that we need to have it at. And then the last value is we have the targeting type. First, we have a reset targeting function in which for each character that is selected with the spotlight turned on, we deselect it, we all turn it off. And then for all characters for players that are turned active, they're set active, so they're all invisible. Now, with our updating targeting type that's within check targeting, we reset that targeting, we disable selections, and then we check the targeting type and access it from the targeting type that the action is declaring. Go through a switch case that depends on which type of targeting it is. Now, at the end of each function, we call the camera, and then in some of them, for example, self, we turn on player characters just in case. Even if it's enemies, we target the active character, and then we select that active character. If it's targeting allies, we turn on all player characters, we target the index of that player character, and then we select that character. And then if we have enough characters to select through, like 2 or more, we enable selection. And then we call the camera. And then enemies, same thing with enemies. We turn on our active character instead of just all characters. We take the index of the current enemy, and then we select that guy, and then we turn on our selection if there are more than 2 enemies. And if it's all allies, we just have a for each. We turn on all the player characters and have a for each to go through all player characters in the list and just select them, turning on their spotlights. And it goes the same way with all enemies. So we go through all the enemies in the enemy list and select them, turning on their spotlight. In random allies, and the same thing with random enemies, we take an index ranging between 0 and the maximum player count. We take the target character and they'll equal the index at which that it lands on. And with the target character, since it's an ally, that target character will get active and then it'll be selected. And if it's an enemy, that enemy will be selected and that enemy will have their spotlight turned on as they're selected. And then going back to scroll targets, this part initializes that scroll target part, and then with scroll target part, it will deselect the person behind it was on, go to the new index, and then select. So it changes the index, and then we turn off the person before we set to the new index, and then turn on the spotlight for that new character. And with camera controller, since camera is being called at the end of each targeting time, we have this switch case for similar to targeting, but just for players. Similar to the targeting, but just for fewer types of functions. With each targeting style, instead of 1 for each, we have 1, 2, 3, 4, 5 different functions instead. Self-targeting, it targets the player, it targets the active character, and it goes from the middle of the arena. With allies, it has a switch case. Depending if it's a player that's active, it'll look at from the third person perspective of the player, from their front perspective of the player, and then it'll look at from the middle. For the enemy, it'll look at for enemies, we will be looking from the back of the player, looking at the enemy that's about to attack or do whatever against the ally or the player character. And then we also have the 2 characters look at each other with their transforms, transform.look at with target character, transform.look at with active character, and active character transform look at with target character. With enemy targets, if you're the player, it'll go from the back of the player and then face towards the target enemies up ahead. If you're an enemy, the enemy will go from the middle. The camera will go meet at the middle of the arena and then look at the full enemy list. It'll look at all the enemies and target that one enemy. And another thing with the player, all other enemy characters will also look at the active character. And then only the active character will look at the target character. And then with all ally targeting, it'll go from the middle of the arena and look at player side, and same thing with enemy, go from the middle, look at enemy side. And with these 6 systems working together, we have the entire game working. So the entire game works all together once we have the 6 systems, and then we have the pieces for the player characters, and they all work nice and well together. They all work harmoniously. They all work in one nice little nest. They work in some sort like a web. They all connect to each other, working amongst each other. Think of it as like a basketball team or a soccer team. You need each person on the field. Some of them could be less useful. Some of them could be more useful. But at the end of the day, it's a team game. Now let's just go over all that we have covered for all the systems. So right now, as we can see, this is the intro that is playing at the start of the game, and I'll just basically right now ignore UI. You can see that the enemy has taken their turn. At the top here, you can see that is the turn order. Currently the enemy was the first to go. We have our debuffer, magical enemy, an attacker, a defender, another enemy, and the healer, and the magical enemy. We have our scrolling system here. We have that double press button system that we have with our input selection. And then let's go decide to attack these red and purple. Purple's supposed to be magical, red's supposed to be physical enemy. So let's attack a magical and a physical enemy. Oh right, this is a debuff. We give him a magical debuff. And now we have our attacker. Let's have our attacker deal a magical attack because we hit him with a magical debuff. Now we have our defender, and then we have our targeting system here. He's able to defend. He's able to select allies, and you can see that it all works out. There's no problem with any of the selections. And you can see all the enemies taking turns on actions once it's their turn. And now let's say we try to kill this one guy over here. And as you can see, all of our allies seem to be losing their health. So maybe we should do a heal allies. You can see the selection appear on all of the allies instead. So let's do heal all allies. Boom, everyone heals. Now let's go hit this guy with another debuff. And then kill this guy. And as you can see, his icon disappeared from the turn order because he is dead. And his body is still there because we didn't decide to destroy him. But he is outside of that list for enemy characters, so he isn't there just being a bother. His body's just there, running away. And yeah, so that is all the systems intertwining together. We have the character animator using animation events to essentially continue the game after taking action. We have our input system being able to have the player interact with the environment. Our systems help our characters take action to give them essentially life. And now, as you can see, there's a whole bunch of UI, and we will explain how these all work in this next part. So as for today, I bid you all farewell, and that is all. That is the end. Goodbye.